I'll set it to 39, give you one more minute if you actually spend that long.
Yeah.
Oh. Yeah. So it's here to 7. Well, it is 3:30, but since we actually only have 2 presentations where this is built for 3, one of our authors couldn't make because he had a death in his family. It's our last presenter is not going to be here, just for your information. If we're looking forward to that one most. Hopefully he'll be able to present that at some future date. But we will go ahead and get started. Hoping to see a few more faces come in, but it's afternoon, right? And everybody's tired of taking the break. But this session is on participatory simulation, including VR, virtual reality work for work zones. And we have 2 really good presentations here. Since we have so much time, we'll have a large amount of time for questions, okay? So we're gonna have the questions asked at the end of each presentation. I'm Jason Williams. I actually am the co-chair for the participatory simulation or the interactive visual simulation subcommittee for the Visualization Transportation Committee. I happen to work at the Turner Fairbanks at the Highway Driving Simulator, and you saw some of the pictures from us that our chief scientist gave this morning. So I'm related to that site a bit. Now on our authors, hold on. There we go. My arrow keys didn't want to work, so. So first up, we have Sabeti on leveraging virtual reality, quantifying usability of wearable and augmented reality systems. And then we'll have the second presentation after. But Sabeti is a researcher with experience in multidisciplinary research projects. His research interests include leveraging emerging technologies such as artificial intelligence, augmented reality, and virtual reality for solving some of the most challenging problems designing, building, operating, and maintaining the transportation infrastructures, such as work zone safety, worker-centered user interface design, evaluating the usability of complex systems. During his PhD, Sepehr has worked across different disciplines and has conducted innovative projects funded by the National Science Foundation, Virginia Department of Transportation, and Leidos. Sepehr holds 2 masters in computing science and in civil engineering, and is a 4th-year PhD candidate in multidisciplinary infrastructures. A mouthful. Systems programs at UNC Charlotte. His industry experience includes an internship. Yeah. Maybe I need a little bit more of that water. An internship with ServiceNow as a UX researcher with AI platform team and technical Thank you.
Sure.
And technical internship with Civil Group at Leidos. SEP is a member of the Data Sensing and Analysis of American Society of Civil Engineers, ASCE, and a member of TRB's Standing Committee on Visualization and Transportation. Thank you. I'm going to bring up his presentation, and he's going to go forward. Okay.
Thank you, Jason, for the introduction. So, hello everybody. Good afternoon. I hope y'all are not tired. So, I'm here today to talk about the research that we're doing, the support of National Science Foundation on leveraging virtual reality to quantify usability of augmented reality in hybrid work zones. So, there are a bunch of words out there, obviously, but the gist of it is how we can use VR to simulate AR in a context that cannot easily be replicated. So, it's the agenda for today's presentation. I'm going to give a little bit of introduction and background and the research objectives, the methodology that we did, the results, and some of the conclusions that we found. So, hybrid work zone safety is one of the problems that unfortunately have been often overlooked in the past years. So, but fortunately, in recent years, there's been a new push toward addressing this problem. You've probably seen the National Work Zone Safety Week, and we've also seen some push from Office of HWA from Secretary Buttigieg on National Work Zone Awareness. But unfortunately, in the past, like I said, there have been multiple crashes, multiple fatalities in hybrid work zones. And the other problem is we saw a decline up until 2016, but again, seems like the crashes and the fatalities are picking up. So it is one of the most challenging and pressing issues that transportation agencies are trying to address. And also on top of it, it's not just this. A lot of workers have sustained life-threatening and life-changing severe injuries in the past that has emotional, mental, and physical issues that will pretty much be with them in their lives. So it is a little bit more than just death. And one of the problems that we have here is like reactive safety systems. If you have driven by a work zone, you just see a bunch of cones there, and the most advanced technology that we are using is like some of these reactive technology that if there is an intrusion, but that intrusion has already happened, like it has hit one of those cones and there is an auditory cue that will go off, right? So it doesn't give the workers much time to react to that intrusion. So, which we call them like reactive safety systems because it is reacting to an oncoming danger. And the flip side, recent technologies, recent advancement in technologies such as AI, augmented reality, and virtual reality, and wearable technology provide a promising potential for delivering real-time safety systems in other domains. We've seen some of these examples in mining. We also have seen some of these examples in vertical construction. But there's a lack of push and technology transfer toward the most transportation infrastructure systems. So we haven't seen such technologies yet to be developed in this domain. And one of the other problems is like you have a technology, you just develop a technology, and it is cool and it does get the job done. But the problem is if it's not usable, if it's if it does put additional barrier on workers in terms of mobility, in terms of distraction, stuff like that. So it cannot be if you think about it, cannot be as useful as you would think it is. So limited information on this usability of new technology is one of the barriers that could hinder potential development. And the other problem is you can't actually deploy the technology that haven't been fully developed yet into the field, ask them to wear that and get some of the information back, right? So it is very hard to test that technology in the context, in the field, so that get some of this context-aware information back. And it is going to be very costly and also complicated. So With that, we started this project with the support of National Science Foundation 2-3 years ago. And what we wanted to do is like we wanted to have AI-enabled wearable-based IT infrastructure for highway works. And what we have here is technically what we do. We have a camera set up in the nose of the work zone, and it monitors the traffic in real time. We have this IoT communication and network between the backend, that IoT, AI module, and the front-end module, which is a pair of augmented reality glasses and a smartwatch. So what we do in real time, we take a look at the traffic, the upcoming traffic. We monitor the traffic if there is anything anomalous, if there is any anomalous pattern, or if there is any intrusion is about to happen. We can detect that in advance, 5-6 seconds prior to that happening, so that we can ship that information to the front end through the augmented reality glasses, and we can notify the workers of the upcoming damage, so that they have either breathing room, some responding, some window of opportunity to respond to that engine, right? So the reason we are using a smartwatch and ARs is like we want to have a full set of tools, so that depending on the danger, we can use different variety combination of tools. Like for example, if we just have the AR glasses, we have only the visual context, visual cue that we can use for notifying workers. And also it does come with auditory modules, so that we can also have some audios going on depending on the danger. We are using smartwatch for haptic feedback, so they are actually combined together to set up like a bundle of front end. So as we ship out this risk from the AI, they will be delivered at the same time to these two modules, and they will process it. If there is any intrusion, depending on the risk that we have identified, we will use different combinations. Like for example, if there is not any risk, we just use this layout that say, okay, everything checks out. If we are in the medium risk, we can just use a low pitch beep and couple with a visualization, right? So if it is higher risk, we can use a low pitch audio, haptic, and high risk. And if there is a lethal and immediate risk that requires immediate attention of workers, we will go full on our arsenal visualization with the color red, high pitched audio, vibration, so that we can get their immediate attention, right? So this is the whole big picture, and we worked on developing each modules to and have a viable product. But one of the problems that we have, like I said, is like shipping out this product that hasn't been fully, and although we do have this prototype, but it's not fully developed yet, right? So it's not an end user ready product. So shipping this out to get some of this information back on the usability and stuff like that is very hard, and it's going to be very costly and everything. So what the idea that we came up with, what if we simulate this application of this AR in VR, so that we can get some of this information back while we are working on improving the usability and other information that we need from end users. So let's use VR to simulate a hybrid work zones in which these workers are putting on the glasses, doing some of these things that they usually do, some of the routine maintenance operations, and get some of this information. But the very first step would be, how close is that gonna be to the actual product, right? So we needed to benchmark some of these things in terms of usability, in terms of like cognitive load, to see if we are actually replicating that, the actual physical product, right? So we wanted, so that was the context. And one thing I wanted to add is like, we also wanted to, in creating this VR, we also wanted to be as close as possible to reality, right? So we wanted to have control-free and room scale VR, so that you can just walk as you just would do in reality, and like pick up stuff as you would do in reality, so that we don't have any controllers whatsoever, and you can just walk free in a room scale scenario. So the steps that we took to this end was, first we needed to have our AR prototype, so we develop our software, backend, frontend, and everything, so we have that ready. And then we needed to do pretty much the same thing for the VR one. And like I said, we wanted to have this room scale and controller-free VR, all the softwares, the IoT network, and everything. We needed to develop that. And one thing that we wanted to, because obviously this is like a preliminary results of the thing that we did was we wanted to conduct this experiment in a controlled and similar environment in the backend, right? So what we did, we used a Wizard of Oz methodology. Wizard of Oz technically is like you just mimic the backend. You just say, okay, hey, these are the things like a wizard. These are the things that I'm doing, and I ship it to the front, so that we don't actually have to go out in the field and do all of those stuff. We wanted to get the similar backend, right? So we used the Wizard of Oz methodology for that, and what we did, we tried to quantify usability, user journeys, and on top of using system usability scale. System usability scale, or SUS, is a well-known questionnaire, subjective questionnaire that has been used in different contexts for a quick usability benchmark. And then we use SUS for that. We also use RSME and NASA TLX for collecting some information on the cognitive load. And we also designed another questionnaire ourselves to quantify the realisticness of the design environment, realisticness of the design task, and similar to user experiences in VR and AR. So these are pretty much the most important steps that we wanted to take. And this is how the technology I just talked about works. So technically, we have this wizard in the backend. We have a IoT network. We have a router that connects our front end and the back end. For the front end side, we use VIZ22, which does come with ANSI 87.1 certificate that pretty much guarantees the safety aspect of that glasses. So technically, that can be a good replacement for the like the ordinary traditional safety glasses that we use, right? So it does support all of the regulations, safety regulations on that. And we also use the Galaxy Active smartwatch, so we develop the softwares. And for the virtual one, virtual AR one, we use Oculus Quest, the same smartwatch. We develop all the softwares, and yeah. So now that we have both real, we call them real world AR and virtual AR. Now that we have this stuff ready, so what we wanted to do, this is like the user journey that we took. So we had the normal interface, we had the same interface in the VR side, we had the warning interface, the same interface in the VR setting, and as you can see, like pretty much the we will also low on the we will light on the haptic side, and again another warning side on both sides, and the danger or lethal interface in the end. And I also wanted to show you a demo of how this works. As you can see, I don't use any controller, just using hand tracking. I pick up the glasses I put on, and the interface now comes. And I have the watch, it gets receives the similar information. I pick up that smartwatch. Obviously, there is something wrong with it, because the voices are, the audios are not like that. I do the inspection. I send it one of the notifications. I pick up these bluer, I turn it up. I blew the obstructed drop inlet, probably because there is a mismanagement going on. So I turn it off, put it back, and then do another inspection. And I don't know what happened honestly here, so it seems like the video is not quite synchronized here, but it was, trust me, on my end. But yeah, so this was the environment that we designed. As you can see, we have the live traffic. Maybe if I maybe from here, that will work, because now that we have some time. it is not. I guess the problem is with the animation that has been probably changed while we transferred the videos. I don't know why, but yeah, they are not synchronized. They were on my end, I swear, but I don't know what happened there. But yeah, I guess the long story short was, if you see here, uh, that you would get a notification on the danger side. And this is when the intrusion is happening on here, and they can react to that danger. Going back to the results that we collected SUS post-experiment. And for those of you who are not familiar with SUS basically it ranges anywhere between 58 to 100. And if you are after all of the experiments that they've done throughout the years, they pretty much, after the percentile analysis, if you are above 68, you are normal. You're better than normal. And what we see after our analysis was we were around 78 in the real world AR, and we were about 68 on the virtual AR. And we also collected the RSME, and those were not statistically different. And we also collected our RSME, and as you can see, the RSME on virtual AR is a lot more than real world AR, because obviously you're adding the element of the interaction with virtual reality there as well, right? So, and these are the results of the NASA TLX that we collected. NASA TLX consists of 7 different questions, and you can also use the means. But one of the things that pretty much was interesting was the physical demand aspect of the NASA TLX was pretty high, right? And as you can see, the standard deviation is pretty large. It means that well, we can attribute that because we wanted to do this control-free and on room scale. So you were trying to pick up some stuff that were not there. So you do not have the weight attached to the objects, the virtual object that you're picking up, right? So this is, we believe that this is what is causing the standard deviation there in physical demand of NASA TLX. And the other thing is that we also found some correlation, interesting correlation between the RSME and means. So it means that NASA, like the RSME, so because NASA TLX and RSME are two different methodology that tries to collect the cognitive load. But we found that they are correlated, which definitely makes sense. But in this context, it means that both can be used, right? And the frustration aspect of the NASA TLX was also negatively correlated with the realisticness. So the more frustrated the participants were, the less they were pretty much likely to rate that realisticness less. And we also found some correlations between physical demand and the RSME in virtual reality, and the also similarity of the experiences that we try to find with frustration. So bottom line is like adding the cognitive problems of virtual reality to that, to AR. Of course, it comes with some problems, and it could impact the results, but still, according to SUS, we were in the acceptable range. So it shows that we are in a good starting point, but we still have a lot to go, to cover. And these were the average of the questions, that the 3 questions that I said earlier about the realisticness of the design environment. We were averaging at almost 5, and the design task at 5, and also similarity of experiences. We were pretty much the average was around 4.5, and it shows that we are still better than we are definitely seeing this positive side, but we still have a lot to cover in the following experiments and studies. So the conclusions that we took out from this study was we were able to somehow prove that we can use VR for simulating AR, although there are some caveats attached to it. So, but pretty much in terms of usability and user experience, there are some opportunities to use VR for simulating AR. And both were graded, this usability of the technology that we use, both were graded above than average, 1C and 1B. And we can also use VR for simulating a task of routine maintenance operations. And one of the things that I also intentionally put in the end is so one of the problems that we have is, of course, the technology, the VR headsets that are out there that are commercially available, right? So for example, with HTC Vive, you can't do hand tracking, you don't have any of those fancy features, you have to always control the environment with your controllers, whereas with the emergence of Quest like two years ago, Quest 2 years ago, now you have this option of hand tracking. It is not still perfect, but you can use that. But the problem is that if you want to do any of these stuff, because the actual objects are not there, so you are kind of sitting out, you're kind of eliminating that weight element into that, so it could impact the fatigue and stuff when it comes to human factor research. So the very next step would be somehow having this notion of immersive mixed reality rather than just non-immersive mixed reality in that spectrum. If you can somehow have a bunch of trackers attached to that objects that you want and bring that into that environment so that while you are picking that object, you can actually pick up an object in reality, it would be pretty interesting to see how that element can also resolve some of the issues that we face. And thank you very much. If you have any questions.
Do you have a question? So is the thought that in practice, people who would be out doing maintenance would be wearing a headset and be seeing both, or?
So the actual product that we kind of envision this as a training thought, like down the road once we have, of course we're going to use this for improving usability and everything, right? The actual product is going to be that AR smart glasses, right? So you put on the AR smart glasses in a substitution of the ordinary and traditional PPE items that we use, the traditional safety glasses that we use. So yes, instead of those, just wear these. And they come with the same benefits. They come with ANSI 87.1, so you're good to go on safety aspect. It does also do other stuff for you, right? So it pretty much also acts as a safety system, right? So, but what we wanted to do here, assuming that we have collected all of the information that we need and we have a final product, so you can just hand them over a pair of smart the AR glasses, adjust them to from tomorrow wear this instead of your glasses, right? Your safety glasses. So we need some transition into that. So we also envision that not only on collecting some of the information that we need, but also as a training platform to get them on board and make it as smooth as possible. Yeah.
So it looks like you have two modules. One is the smartwatch, and another one you have the AR goggle. Do you think which one works better? Because now you just consider it as one system, but actually they receive the two kind of information. Can you distinguish the impacts of the two different modules?
Yeah. So that's actually a very good question. They are though part of one system. So they receive the same information from the AI backend. So there is nothing different. The only thing that is different here, the kind of cues that you use in AR is visualization and audio, right? You use smartwatch for haptic and for vibration. At the same time, let's say there is an intrusion, right? And we identify there is going to be an intrusion. At the same time, all of them are gonna come off, or they're gonna go off, all of them. Visualization, audio, and haptic. And the hope is, because it's a loud environment, right? So there is a lot of noise. We cannot just rely on audio. We cannot just rely on visualization. We want to have the opportunity to have to use several cues so that we can get their immediate attention. Which one is more successful? We are actually doing that right now. We just wanna see what if we just use vibration instead of all of them. What to bother if the vibration is going to get the job done? Why do we have to? Of course, the visualization aspect. It's not just safety. You can also bring a lot of other benefits. You can maybe there's an adverse weather, right? So you go and you just want to say in some of these regions that down south, so you have microclimates. Like out of nowhere, it's just gonna rain. Like and when I say rain, it's gonna rain, right? So you can also let them know, okay, hey, there is this microclimate happening. You just need to wrap up your stuff in 10 minutes, right? You cannot deliver the same kind of information with just smartwatch, right? But on just safety aspects, we are actually trying to right now measure which one is better in getting your attention first.
I feel like if you're out on a job site working with power tools, there's going to be so much vibration that you're probably not going to feel
Exactly.
the watch vibrating. So that being the case, I guess why not stick with, like, have you thought about just kind of sticking with the glasses and the audio and the visualization? Like, what made you say, yes, we should also have the watch?
Yes, that's actually a very good question also. So because what we want to do is like we just kind of want to be like an agnostic of the kind of things that the highway workers do. Some of them do a lot of drilling, so in that case vibration probably is not the best option. Some of them just do these like leaf blowing and the dropping light work. Some of them just inspect, right? So we want to have these tools, and of course in some cases it's one of the cues is not going to be as effective as other cases. But we didn't want to like pretty much limit ourselves to just say this product is just going to be for this specific highway worker. We just want them to like include everyone. And other than that, we can also collect a lot of other information on smartwatch. You can have their heart rate. You can have their location. So you can, for example, if you have a worker who is a little bit more, let's say, risk-taking, has a little more risk-taking behavior than the other one, and often a step aside out of the boundary of work zone. So you can also notify that worker, hey, you're a little bit, you just need to be a little bit more careful of your surrounding. So there are also more data that you can collect with the addition of that.
So I had, was wondering if you took any cognitive load data for just the virtual reality task itself without the AR part as like a baseline measurement.
We didn't do that, but that's exactly what the things that we are doing now. So we want to like have a more database and benchmark. So and one of the things that we are also actually doing. So who says these user interfaces that we came up with are the best? So we want to have nothing and then have different design configurations and see which one is better. So that is actually something that we are actually doing right now.
What's been the reaction to this from others? Is there any pushback or opposition at all? I mean, it seems pretty like, yeah, let's go.
Yeah.
But, you know, just waiting for the technology to get there. But have you gotten any actual pushback or?
We actually did one round of usability testing with folks in MinDOT, and workers actually they did dig this technology. So they were like, yeah, why not? We have a lot of problem. Though I would have to say from, if I'm being quite critical, it's like, maybe that's coming from the fact that they don't have anything, so they would accept anything that you just push out because they are getting like crushed out there. But overall, from that limited usability test that I did, people were actually very interested. And also in managerial level, we also had multiple conversations with different people. And it seems like, because one of the problems that they always have is the price, obviously, the price tag. So some of them might ask why Vuzix, why not like Trimble, HoloLens 2. So that thing costs $6K. This one used to be like $1,300, now it's like only $700. So it's not that expensive. You can just and it is going to be like for each individual, right? So for each one of your crew members, you can just get one of these. It's going to be almost $1K for everyone, for each one of them, and they're good to go. So the price increase that we've seen in the past couple of years actually is helping us in advertising this, but they seem interested. Yeah.
So looking through these, it seems like it's a good integrated system when you consider other augmented
Exactly. So one of the other things that, so if you were just talking about, there were a bunch of booths here that also do that, use AR for other purposes as well, right? So one of these things that we also have in mind is like somehow these stuff, because we see this push that somehow we are trying to include AR in everyday tasks. Even if you're out there inspecting a bridge with one of these ND non-intrusive that the keynote speaker was talking about, so you can also have the same thing. You can do the inspection, but you can also use this in the back end for your safety purposes, right? So if there is any problem, then we can also use this kind of technology there. So they kind of complement each other in future. So each one of those crew members can have one of these and just do their job.
So another interesting question is for the connectivity to sensors for the intrusion and all. Those aren't quite standardized yet either. So were you utilizing a particular standard? How did you define, since you're actually creating a full product, not just a prototype, right?
Yes. We use TCP/IP, and TCP/IP in IoT is like the one with the handshake. Usually IoT stuff, they do UDP because it just push this stuff out and don't care about the handshake and stuff. Because
Or the sensor equipment, are those ones that you also sell for the intrusions?
yes, so in terms of the equipment, we just have one camera, one back-end GPU. It could be Jetson Xavier, it could be whatever you have, right? So we have that bundle. So the streaming, the GPU like takes the streaming live stream from the camera and just process it and like ship it out with the router that we have. So it's going to be a local router communication between the front end and the back end through the TCP/IP protocol.
Because one area of connectivity is with the devices that are warning drivers that you're
Yes.
going to intrude.
Yes.
And so since you only really need one sensor system for that, you can alert your workers as well as the driver
Yes.
with the same sensor, right?
Exactly. So if we can use the same IP address or same network, everything here can be connected to the same networks that we have, for example, for your V2X or V2V or whatever, right? So we can definitely, because they're pretty much like if you under the hood, they're the same network, right? They also use TCP/IP, so everything can be connected in the same network, and everything can be worked down there.
What's the reaction of the guys out in the field using augmented reality? Like a lot of them are blue collar guys who maybe don't do that as a normal thing, and they accept it to working with that there in their eyes.
Yeah, so that actually what they said about the MinDOT folks, so they were like MinDOT highway inspection folks, and what we found out is like they are quite interested, like I said, is either from the fact that they don't have anything or they are interested in technology, which I highly doubt, but especially a lot of them were a little bit suspicious of the small watch because they're quite concerned about their privacy, and I definitely understand that. But from the aspects of the safety aspect of the technology, they were quite interested on trying new things, and a little bit surprising to me, but yeah, I mean, they were interested, yeah.
So any more questions? Because we probably should be switching speakers very shortly, or any more? Okay, thank you. Very good. So our next speaker is Zhu Qing. He's a PhD, a postdoctoral fellow in civil and environmental engineering at the Department of the University of Missouri-Columbia. His research focuses on transportation safety, human factors, and applications of virtual and augmented reality technologies in transportation. Currently, he works with the Missouri Department of Transportation to implement an immersive virtual reality training module to enhance the work zone inspectors training effectiveness and engagement. Before joining MU, he worked as a postdoctoral fellow at Georgia Tech from 2019 to 2021. He earned his MS and PhD degrees in civil engineering from the University of Missouri. We're gonna switch computers to. We should just be able to plug in the HDMI here.
Thank you, Jason.
Okay, today I'm going to talk about a topic everyone probably feel very comfortable and very common. So it will be the flagger training. Have you seen a flagger recently over the last 2 weeks? No. Okay. Okay. So first of all, I just want to, in the beginning, I just want to talk about the why flagger training is important, although no one answered me this whole flagger recently. First, flagging operation is very common in our daily life. Sorry, I'm wrong about the statement. If you live in an urban, you may find the flagger near the construction or maybe the maintenance sites. And if you live in the suburban or rural area, you may find them just like on a two-lane road, because that's what most the common road we have. The common road we have in the entire national. So second, the flaggers actually ensure the safety of themselves, the crew member behind them, and also the traveler. So here are some bad examples about the flaggers. As you can see, the first one is like there's like a distracted flagger, and he didn't secure escape route for himself. On the other hand, we also see that there are more and more distracted drivers. So it's like they together put the flaggers in a bad situation. And the third one is last but not least, the flagger training is mandatory by many state DOTs, and the flaggers must be certificate or recertificate every 4 years. Usually it's the first training course for the highway construction worker, and it's necessary for the future certification, such as gear up, work zone technical, and advanced work zone training. So it's like keep going. And here I just want to take a quick overview about the current practice for the flagger training. So the traditional training usually cover, as you can see, the MUTCD. If you're familiar with the transportation, the control device, usually we just focus on the Chapter 6E, and each state actually will adopt the MUTCD, and sometimes they also have its own version. So in the state of Missouri, we have the MoDOT Engineering Policy Guide. So it's another material they have to be very familiar with. The third one is the MoDOT Flagger Guidelines. And the fourth part will be additional traffic control device, such as automatic flagger assistant device. The last part I was talking about the training the medians. So they are not very fancy. So here you can see slides, reference, quiz, exams. So if the training facility allows, for example, they have enough space, so usually the trainer will have some field demonstration, like to show people what they should do and how to do it correctly. And here we just like provide some comparison, do some comparison between the traditional way, the training module, and the field demonstration. So here you can see that I think the traditional module still works very well, but it's not very engaging. For example, usually it's a full day or maybe 2 days training, and the trainees need to review a lot of materials we just mentioned before. So people will get lost their interest pretty quick, and people also has a very limited communication, because it's more like one instructor is leading the entire view. They will not barely talk with each other, so they have a limited construction. On the other hand, you can see the field demonstration at the bottom. So that's the most exciting activity, but it's a mock-up. So usually just like a one-person demo. So we propose to add the virtual reality module to improve the engagement and also allow them to practice their skill together, including like a communicating skills. So I will maybe just show you the example later.
And here, we just like, this is what we proposed. We want to add the immersive VR module to the current learning module. So we still have the current learning module, but actually we have something more, just like develop the virtual reality modules for the different scenarios. And we embedded the interactive scenarios into training. And also we provided the real-time feedback to the trainees. And here I just show a very quick, like how we developed the module. I think some of the presenter this morning has already mentioned some of the tools they use. For example, we have the full control of the VR module development, from the modeling, simulation, display, and also the collaboration. It's all complete in-house. So we have a full control of all the system, from the roadway design, traffic control device, to the vehicle movement, until the end, how to use the cloud server and how to connect the different players into the same scenario. And here, I want to show you the immersive module, what the training looks like. So first of all, we offer a warm-up session. It's like 5 minutes, just allowed everyone to practice how to turn the pedal, teleport, and move the traffic cone. And this is the task actually they need to do. They need to set up the flagging operation and also stop the approaching traffic, release the traffic, and also prepare to stop the next traffic coming. And if you can see, it's a circle, and a pair of the flaggers, they need to work together, because if they don't work together, we may see some crash. And here I just want to show some instruction we gave to the workers. So I'm just have some video to play. So here, the first one, we just show them how to turn the pedal. Just use the trigger of the right hand, the controller. So here you can see this is the view from the instructor, and the bottom view actually is from the training themselves. So like do some hand gesture and looking around. So that's the first function they need to learn. Okay, the second one is a little bit tricky about the teleporting, because remember we are talking about the frontline worker. So they are not very familiar with VR. So usually I ask them the question, did you watch Star Trek? If yes, I say, okay, you probably know what's a teleporting. If not, I have to spend some time to explain this one. So here, it's like a task we ask them to do. So they have to teleport from the yellow circle to the blue circle. And they have to and once you reach there, and they will come back. So we offer this as a practice. Is it hard for you? Just ask a question. We're very quick survey. Is it very hard?
The biggest problem with teleporting is some people think it causes a little bit of sickness for some people.
Okay, because we find it's really hard when we have this idea to show them the teleporting, because we have some limited space. We cannot like offer people to walk around. And the third one will be the moving the traffic cone. So here you can see we ask them, once they feel comfortable to move around, we ask them to pick up the traffic cone and line them up. So it needs some practice. And also they can only use left hand, because right hand is always holding the pedal.
Do you have issues with left versus right-handed people? Normal, left versus right, why don't you switch?
Good question. But the flagger training required you always use your right hand to hold the pedal, because you are standing, you have to keep the pedal close to the central line to show the traffic. That's a good question. Okay, here I'm going to show you the scenario we developed for the flagger training. And it's based on the typical application 10. So it's a lane closure on the 2-lane highway using flagger. So here I want to show you, this is the entire work zone setup. So that's how the work zone setup. We have a advanced warning sign. We have a transition and we have the work activity area, and we have the taper back. So there are different areas. And also I want to show you some pictures of the scenario, because we work on this one, just like Jason mentioned that we work with Missouri Department of Transportation on the work zone inspection before. So actually we have those models created by ourselves. So you can see that we have the truck mounted attenuator to protect the workers, and also we have all the signs already created by ourselves. And then the bottom one actually is like a fleet. We generate the color of the vehicle and the type of vehicle actually will be randomly generated, because that will be part of their communication. The flagger need to tell the other end what's the last car, what's its color, and what's its type. So it's actually something they need to pay a close attention. And here I'm talking about because it's a collaborative research, it's a collaborative training. So actually we connect them with the different climates and the different the VR headsets. So we have 3 roles in this training. So we have flagger 1 will be as the lead flagger, and we have flagger 2. And the third one will have the instructor. He just like provides the live feedback. So in the work zone, as you can see that the lead flagger will have it's like make a final decision who should release the traffic first. And here I want to show you a video, but before I show that, I want to just like show you different, explain each screen a little bit. So this one, the top left, just show the flagger 1, his view, and the left button will be show the instructor view towards the flagger 1. On the right hand, the instructor view will be on the top, and the flagger's view will be on the bottom. And here, I just add one more screen to show you the body gestures. And you can see the difference. The flagger 1 is actually on the closed lane. So he has a 3 traffic cone in front of him. He does not need to move the traffic cone. But for the flagger 2, because he's on the open lane, he has 1 cone, but he needs to frequently move to release the traffic and put it back to stop the traffic. So here I'm going to show that. You can see now at the very beginning, both of them, they just trying to set up the work zone. And they need to teleport back to the shoulder and change the pedal, and also show the hand gesture. And now they will begin to talk. I didn't turn on the video, the voice, but they are talking about, I have a traffic cone, and they were other side will say, okay, I also have a traffic cone, so you can see that. And they will talk about who should release the traffic first. And once they stop the traffic, they need to move close to the central line. So the traffic behind the first one can see the flagger further, from the further place. Okay, now both ends stop the traffic. And they're talking, okay, I'm going to release my traffic. And the flagger 2 is remove the traffic cone and bring it back on the shoulder. And now change the pedal and switch. And while he's talking, I'm releasing the traffic. And I have 3 vehicles to come, and the last one will be the yellow sedan. So this is the communication information they provide to another end. Once he releases the traffic, he will remove the traffic cone back to the travel lane. As you can see, he already switched the pedal. And you can see the flagger 1, actually the vehicle is coming from the other end. And here I'll notice that, okay, the last one will be a yellow sedan. And now he's going to switch the pedal and direct the vehicle to move. So that's the entire circle about how a pair of flaggers work together and the practice how react to the traffic, and there are also the communication skills.
Does the traffic always follow the signs?
Good question. That's one of the scenarios we create. And also we want to try to create some like a distract driver so they can run away from the traffic. They have to identify for example, the first step, they have to identify the emergency roads for themselves. So they can be a part, but not including this training, but actually is a good scenarios for the future. Okay, here I want to show you, I forgot to ask a question. How am I doing? I mean, the flagger doing. Actually, I've recorded one side. How am I doing? Good? Okay. we provide, based on the feedback from the instructor, we'll provide a checklist. So you can see, did I fully extend the pedal? And once the traffic is stopped, where should I stand? So that's a question. And actually, that's a checklist provided by the instructors. And here I want to show a result of the focus group study. So we tested the system with our MoDOT work zone staff. So we have the staff from the MoDOT Central and the St. Louis district. And they are very skilled workers. So you can see that the average work zone experience is almost 19 years, and 10 males and 1 females. So that's very general about the VR experience. So 65% never used VR before. So actually that's the most challenging part we are facing. In our previous research about the work zone inspection, we found that number even higher. It's up to 85%. So not too many people has tried the VR before. So we use, I think we just saw so the previous presentation said that using the systems usability scale. So we use the same system to ask them the feedback about the 10 items question you can see on the left side, and the 5 response options to measure the usability and the learnability. And the score will be ranged from 0 to 100. Besides that one, we also have the self-report engagement questionnaire and also the general feedback on the VR. So the results, the SUS score is 78.6. So I think it's above like a range, our average score will be the 68. So we're like a good, but still need some improvement. And also on the left side, we ask about the engagement. So the result shows that the VR module can increase the users' intellectual, social, and also affective engagement. Because, just I mentioned, it's a 2 days training. They need something to practice and bring them back to the training. So after the training, actually they are more active in the training module. And also it kind of provides some topics for them so they can share their experience in the class. And also they feel good. I mean, if the DOT adopt to some technology for them and to train them better. And here's some next steps we are going to do. The first one, we found that the DOT staff have the limit VR experience. So what should we do? The first one is we are offering step-by-step the VR tutorial. So I know probably it's like a very basic form. I'm thinking because I'm talking about the visualization community, but people will think, okay, that's basic. But still we want to provide like a step-by-step, the tutorial for them. So we can increase their exposure of the VR first. And also another thing is right now, it's still like a pretty rough. So everything has been changed by code to do everything, but we want to create a UI system for the trainer so they can run the program themselves. It's challenging. And the second part will be develop Unity, the netcode, the multiplayer version for the local network when internet service is not available or reliable. Like I mentioned at the very beginning, the development, we use a cloud server. But when we bring the VR headset and computer to the, usually we bring to the district office, they have the internet, they are great. But sometimes we'll also have some training at the project office. So they don't have like internet. We couldn't run anything because they don't have internet, or the internet speed is too slow. So we have to consider about a local one. And the third one is we want to blend it into the VR Flagger module in more training. Now it's just like a focus group, has a limit, the people has tried it. But now we are going to bring the Flagger training, but also the like a mid-level, so the work on technique and course, so we can get more data, so we can evaluate the impacts of the VR Flagger module on learning and returning. Okay, so that's all about the Flagger training. And one more thing I just want to show that, I mentioned that we have the work zone inspection, and also we post our all VR, the training content on our own the YouTube VR channel. So here I'm just open the link. Here you can see, oh, oops, I have to. So we also post our the VR training. Unlike the design side, I know that design in the previous presentation, everyone want to present a good design, but for the work zone inspection, actually we ask them to find all the deficiencies. So we put a bad design, bad examples intentionally in the drive-through the scenarios. And I just sometimes I just am amazed about this one. So now the YouTube actually they support the 8K resolution, so it's pretty high. So I just want to show. So this is like an urban environment, but just like we show that it's if it's a flat screen, you can rotate it. Look at the vehicle you are driving, and but it also required good internet service, because 8K, that means you have to download the video much faster, and also have some vehicle running from the other end. I can feel there is some lagging. Okay, so this is one example, and we develop near the 10 different scenarios based on the different typical application from the MODAT engineering policy guidelines. I think that's all for today. So if you have any question. Okay. Yeah.
So are you working with ATSA on this? I mean, they're the ones that do some national training, if I'm not mistaken. Right?
No, we are not working at Shan at this time, but we still mainly work with Missouri. We are not, but we are mainly work with Missouri Department of Transportation. I know they have some training.
Missouri?
Yes.
Okay. I mean, I just see the opportunity to do this nationally, so I just was curious.
Yeah. So we are still like a very trying it out.
Oh, I see. You're in the prototyping phase.
Yes.
Okay.
So I was wondering if you checked out, I know the VR immersive value, but what about just doing 3D graphics on like monitor or large monitor on impact of that?
So the way we want to use the VR, because we want to have the interactions. Because if you just like on the big screen, what? Sorry, could you just repeat your question?
Well, I'm kind of wondering because you skipped it. There is no CBT type of training with, I guess, for these training settings, right? They aren't using computers at all.
They just like a field demonstration.
So they haven't tried to use computers to help with the training at all. Okay. So because you're just making that leap entirely to
Yes.
this virtual.
Yeah.
And I guess the other question was, on the other side of that is AR, as in a field site from, you could use AR to add the traffic for the safety aspect for a field site.
Yes. So I'm just thinking about the cost. Maybe the AR will be cost more, and it's the anchor technology maybe not that feasible, but VR, because we already have the work zone inspection, the program already, and we just like reuse most of the assets to create this program, to create this module. So it's really easy for us. So we already have all the TA. The only thing we are going to do is add the interactive functions for those objects in the work zone, and also adding the network function. So we allow the 2 players. Sorry, I have to use the term about the players. Actually, it's more like a game. So 2 players join the same network.
Yeah, I just think that as more IoT type devices come into work zones, you're gonna have more and more complicated training required anyway.
Mm.
And it's gonna be a lot more than just flagging at some point, because they aren't gonna just keep moving a cone around, they're gonna have some automation to help with that at some point too.
Yeah.
And there already is, of course, with work zones.
Yeah, so we are very, very specific. I mean, we're trying to identify the needs very carefully, because I know different worker has a different duty, and they may have a different training, the content. But this one we target the flagger only. Just like the drive-through video you see, we are designing that one only for the work zone inspection, work zone inspectors. So we have the different the training module for the different rules in the DOT.
One other kind of question on the locomotion aspect of it. You mentioned that it's difficult for most folks to jump into VR. We're also struggling with that with a lot of our public engagement. What other locomotion strategies have you considered using, and have you considered maybe implementing multiple
So,
options?
okay, that's a good question. Actually, I'm communicating with some of our faculty staff in the College of Education. So we're trying to borrow the idea of the game-based training. So if it's a game, we have to keep it like a random mode. So we have to add something. It's not repeat every time, repeat the same the content to everyone. And also we want to, it should be, they have a 4R. The 4 words start with R. The second one be rapid. So we're trying to provide the simple, the tutorial step by step, but actually the training will be relatively short. For example, for one circle about a pair of flaggering operation, it's around 2 or 3 minutes. So we're trying to limit the motion sickness or anything by reduce the practice time. So I want to control the time very carefully.
Yeah, because some games use alternative to teleporting, you just push the button, go forward wherever you're looking.
Mm.
That's an alternative, but some people are more sensitive to that
Yeah,
than
and
they are with teleporting, so you can't win them most.
Yeah, there's point and click too is one that we're also looking at. You just point somewhere and it's preset definition. So if I'm looking in a direction, I press forward, I get the same screen darken, light and effects that reduce motion sickness, but I only have a preset track I can move. That helps simplify a lot of our interactions
Yeah.
as well.
so actually
The trainees have to decide where they're supposed to be, right? So that's part of the, course.
okay.
See if they go to the right place, is that correct? Or you have it predefined?
Yeah. So at one thing I mentioned in one of the slides, I mentioned about the wireless adapter. So the ideally is that if we have the wireless adapter, that means like the Quest 2. So people can actually move freely. They don't need to use the teleport, but it's required a lot of space. And a funny thing I just want to share, that once we went to one of the project office, they offer us a kitchen to train their staff, because the kitchen is the best place they can find. Either way, we're using the hallway or the kitchen. So we pick up the kitchen and we move all the table out of the kitchen and do our best. So that's the reason we have to teach the people how to use teleport. We don't have that space. Even for most of the training facilities, they don't have like, for example, for the one lane, the flag training, it will be 12 feet for the travel lane, and mostly that's another 6 feet for the shoulder. And also you think about the length of the between the traffic calm, and also there's a safe space. It's another 10 feet. So we were talking about 18 feet by 10 feet such a large space, and you have to prepare double the space for the 2 flaggers. Yeah, so teach them teleporting step by step.
How did you determine that the flaggers were the best kind of scenario or use case for this type of training? Was there a certain amount of them, or just lends itself well to that activity?
So that's why actually we work closely with instructors. So they review all the work zone inspection. They found all the most common error or maybe deficiency they find in the real work zone, and they want to us to create the similar scenarios. Sometimes before the basic one, like a setup work zone, release the traffic communication, actually there are some very challenging scenarios we are developing. For example, emergency vehicle come. So if there's one end has an emergency vehicle, what's the best practice? So they need to, that's why the lead flagger is so important, because he will decide how do we release the traffic or hold the traffic. And also he have to remind the other one. If you see one emergency vehicle, usually you will see another one just right behind that. So you have to wait maybe even longer to hold the traffic. So if you see there's a fire truck, and probably you will see the ambulance right after it. So there are a lot of things they think are very interesting, and we just like help them program that scenarios into the VR module. Okay.
Any other questions?
Thank you very much.
Everybody has almost 20 minutes that you can do whatever you want with. Before 5 o'clock in the program, we have the reception starting from 5 to 7. Assuming over in the bigger rooms, but. Very good. Just make sure we didn't leave anything. It's probably the
animation pad, yeah.
PowerPoint does not change devices very well. I've tried to bring some PowerPoint stuff in, and let it take 4 minutes.
Yeah.
So
Hit or miss.
I know the problem. I had the same problem before. So like you want to synchronize to create a video, different video on the same slide. So actually I just like combine them as one video.
Yeah, I should have done that. Yeah, I should have
Yeah,
done that. I
they-
should have posted on YouTube or something.
The animation stuff works on the computer you build it on, but it won't necessarily,
Transfer.
it's the way they do timing. The timing
bring
is not
VR
literally
to go
real
try
time.
this?
I didn't
Just the
have
way
it.
It'd be a good activity for during the
Yeah.
reception. Everybody has
Well,
raising their hands and
I was
they're trying to
thinking
figure it
we'll have
The last one.
maybe a little bit of room. You
want
can,
to-
if
I will
you have some
actually-
props, you can bring it to the annual meeting.
Annual meeting.
Well,
Because
originally,
I
I
was
actually
like
moved to Ashland.
I was trying to reach out to see, but they said, okay, they are just like a follower, like a
nice.
member can present to the group in the interactive presentation. So I didn't bring it, but actually I have a computer, so
Right.
if we have like a few, I can show everyone.
Somebody out
I
there.
didn't bring it, but there's, yeah, I
saw
saw
somebody
somebody
online
that used their company.
So maybe next time I will show that. Probably I was just like, nowadays I'm still like, changing from the cloud server to the local server, because cloud server we still have to pay for
Well,
it's a game
that's when you
changer.
don't even have any issues with trying to keep anything secure, they don't care. Just don't allow it.
Evidently North Carolina.
Florida's our bread and butter, but yeah, we
Yeah.
do, basically
It's
southeast,
very
West
interesting
Coast,
when you
Oregon.
Add and make a
Austin's
scenario.
seen a couple times,
scenario
around
construction
on IDs
kit
and
for
we get the
constructors.
conferences.
So
Change
the challenge is this
Let's talk
year,
about it.
it's really hard
Yeah,
for
it is, I mean, that's.
the flagger training because this year, over the pandemic, so like I mentioned, the flagger need to be recertification every 4 year. For many
Yeah.
certification, they need to redo. So actually, right now, they have like a backlog for the people need to get recertificated. So most of them, it's like their age is over like 70, 45,
Yeah,
and even
yeah, higher risk.
higher
It's
risk.
always good.
And
Yeah.
we were thinking this one maybe works better with
Yeah.
like a new hiring for the younger generation. I mean, we
Yeah.
expect that, we didn't know that, but we are looking for maybe get some feedback from that side.
Well, this is where you can, I mean, you can easily set up the
Yeah,
VR
yeah,
stuff, I know it's more
So
expensive,
he showed
set up
the,
a
like,
VR stuff in a training facility
Yeah.
and design for it to be the right size where you actually physically walk, the distance, et cetera. But I understand it's supposed to
Yeah,
be
like
like
over-
portable.
Yeah, it's
Take it
portable.
anywhere.
So that's what we're
That's much tougher and you have to, yes, like you said.
No,
build
nothing
in
was populated
some
in the back up
mobility.
yet, we're all like waiting to see
teleport or-
what rides out that
Yeah,
What
way.
you could,
because
what I would
the first I saw
suggest
was,
is that, just like games, it
after the
depends on the
trough
person a lot,
collusion,
on what they feel better with,
collusion,
is to,
after the trough
you could train to say, hey,
collusion
here's the
is
teleport,
coming
if
back
that
to
makes you
what they
feel
call like a productivity.
iffy,
So it
then
wasn't
here's the
top,
trigger
but it
button
was
to just
better than it was.
push
You're in
when you
navigation,
move, if you're not
that's
using the
the
trigger
big
button or ready to
breakthrough,
switch the
it's not
sign.
this niche
So-
service.
So you're not really physically having them turn the sign, are you?
We're not just like a by
Cause
trigger.
you could do that
We
by
could
just
do
putting a
that, but
sensor on the
we
sign.
tried that one,
It's more expensive,
If it
cause
propels
those
us
sensors are
to,
like $150 a
things
piece.
that,
But, and
we had.
the
in
sensors
mind,
can
that
lose
I personally think.
connection if you don't have enough.
I'll just have
And
a
also the
IQ.
motion base have to
Get
capture all
excited.
the sensors.
I'll be
in the same
disillusioned,
space.
but,
Yeah,
you know,
I mean,
in the
so
end, I'll.
that's the same thing, if you're using 4
Yeah,
sensor
you're not old
cubes.
enough.
There is one thing I didn't
That's
mention,
probably the problem.
there is one thing I
I'm telling
didn't
you,
mention,
man, this was
that
Dick
it was
Tracy,
something
you
that
ever heard of him?
all the
Yeah.
flaggers, they don't have,
You know,
I mean,
this
they
was like
have
a-
their feet
Yeah,
in, at,
dream,
in
you
the
know, to
training,
be able to
but
have
when they
the
lower
watch
the
and be able
shoulder,
to
you will see they lost their
connect
feet.
with
just
things.
like-
Because the tracking's
I don't
on
know
the
if it's-
headset.
I don't think
But
it's
you weren't,
video
you were not
or,
using the Vive, you were using the,
FaceTime or-
Well,
I mean, there's probably a watch out there.
But
that
it's-
does it.
well, you should be able to calibrate that,
That's
because
right.
in the
It
Vive
catches
Pro
on
at least,
enough
I
One
haven't
day
used as much the lower than the Pro, but the Vive Pro, calibrate to the floor, too.
Yeah, but we have to create the animation for the entire working and also being done.
Next year, right?
That's just like
Oh, well, you don't have the sensors
Oh,
other
really?
than the
Mobiles
gears.
on.
We don't
So
have
if
that
they're,
one.
if they're just doing like
Like
this.
That's the
it
body
won't
just
know.
like merging to the
Right,
ground.
it doesn't know if they're
Partners,
bending
but
the
they're
body, you're
partnered
right,
with
without having the
that,
sensors,
all your
but,
phones are coming
yeah,
out
the
with
sensors are gonna get cheaper eventually, especially since.
And
they're
we
gonna be used
tried out
for-
the different versions, so another version is just like they don't have their feet, just like a normal avatar. People think, okay, it's not a big deal, we still like they prefer to have that feet, so that's just like some common way they see from folks group, so that's really the particular.
Well, you can put some intelligence into your